Hey everybody, welcome to AP Stats Lesson 8.3, which is on estimating a difference in proportions. Yesterday in 8.2, we were just estimating a single proportion, finding a confidence interval for one population. And we talked about the three different conditions that had to be met. We talked about the four-step process, how we could put this in on our calculators. A lot of that stuff is going to hold true today. The only difference really being that now instead of just one population, we have two separate populations, and we're trying to find an interval for the difference between those two population proportions. Okay? So this opens with a Skittles activity, and it says, two of our friends were arguing about Skittles. Friend A believes that there are more red Skittles than any other color, whereas friend B thinks that the flavors for Skittles are evenly distributed. In other words, that there is no difference. So, being the statistical studs that we are, we told our friends that we would do some statistical procedures to determine who is right. Okay? So, since it would take too much time to compare red to each other color, essentially what we want to do is we're just going to compare red to green for right now. Had we actually been in class in non-COVID structures, I would have asked that everyone had their own bag of Skittles, just a fun-sized bag or something, and you would basically count a couple things. How many red Skittles you had in your bag, how many green Skittles you had in your bag, and the total number of Skittles that you had. We would share those out, and what we would do is we would find class totals. Okay? And ultimately, I just kind of used some numbers from previous year's data, but our class sets here had a total, when I took everybody's reds and added those together, 243 reds, 231 greens, a grand total of 1,350 Skittles. So the class proportion of reds was 18%. That's what we get when we do 243 divided by 1350. And the green proportion, sample proportion, was about 17.1%. Okay. So we're going to come back and use this data in just a little bit, but I wanted to give you a little contextual knowledge. So as far as the conditions for constructing a confidence interval for a difference in proportions, it's the same three conditions. Okay, random, 10%, and large counts. And as you can see here, it's the same as single proportion, but we're just taking the second population into account. So when it comes to the random condition, we want to say that it's both random and independent, right? The red Skittles aren't going to have an effect on the green Skittles and vice versa, or any type of context. The two populations are independent of one another. 10% condition just has to be satisfied for both populations. Sample size of population 1 is less than 10% of its population, and sample size from population 2 is less than 10% of its population. And lastly, the large counts condition, same as before, okay? This was what we had yesterday, and we just have to do it a second time for population 2. It's also good enough to say, again, that the counts of successes and the failures are at least 10 for all four groups. Okay? The AP exam tip just kind of mentions what I mentioned with the random condition. When we have two populations, we want to say that not only are they random, okay, not only are they random, but they're also independent of one another. Okay? So let's take a look at our first example here. In example 1, a survey asked independent random samples of adults from the United States and Italy about the importance of brand names when buying clothes. Of the 2309 U.S. adults surveyed, 26%, or 600 adults, said brand names were important, compared to 22%, which is 232 adults, of the 1,058 Italian adults surveyed. Let P of U equal the true proportion of all U.S. adults who think that brand names are important when buying clothes, and P of I be the true proportion of all Italian adults who think name brands are important when buying clothes. What we want to do is we want to check if the conditions for calculating a confidence interval for P of U minus P of I are met. Okay? So, our random condition, we want both random and independent. and right in the very beginning, a survey asked independent random samples. So we can just simply say stated. Okay, as far as the 10% condition goes, we want to make sure that our sample size of population 1, 2309, is less than 10% of all U.S. adults. That's definitely true. Okay, there are more than 23,000 U.S. adults. Likewise, for Italy, 1,058 is less than 10% of all Italian adults. Okay. Now, I don't know the population of Italy offhand, but I'm very, very confident that it's more than 10,000 adults. So, we're good here on our 10%, right? We're checking it for each population. And then lastly, our large counts condition. Okay. We see that we have 600 adults. Okay. So for US, successes was equal to 600, which is greater than or equal to 10. And then failures would have been the remaining 1709, which is obviously at least 10. And then for Italy, our successes was this 232, which is greater than or equal to 10. And the failures were the remaining. So if I were to do 1058 minus 232, that's 826, which again is obviously at least 10. Therefore, all of our conditions are met, and that's all we had to do in number 1 here. Okay? So example 2 is asking you to check the conditions from the Skittles activity. If you want to try that on your own and see what you come up with, go ahead and pause the video and resume when you're done. Otherwise, just go ahead and keep watching. Okay, for the Skittles activity, okay, we can assume that samples were both random and independent. We had 243 Skittles that were red, which is less than 10% of all red Skittles produced. Likewise, 231 green Skittles, which is less than 10% of all green Skittles produced. Large counts conditions, okay, we had 243 successes, which meant we had 1107 failures, and we had, essentially we could have just said 231 successes compared to the 1,119 failures, okay? Either way, all 3 conditions are met. Again, stressing random and independent up here. Now, notice this is what we would call a 2 sample Z interval. Okay, the 2 sample Z interval means we're taking 1 sample from each population. We have a red sample, we have a green sample. Okay, now the confidence interval, notice how it changed. Yesterday was just p hat. It wasn't even p hat 1 because there wasn't a decipher. It was just p hat plus or minus Z star. But now we're taking a difference of 2 populations, so that p hat now becomes p hat 1 minus p hat 2. And this before was our standard deviation. But now we have 2 populations. So if you remember this from before, we just do the first one, add the second one. Okay, all under one big square root. This formula is also going to be on that AP Stats formula sheet that's available on Schoology. Okay, so that's the difference in our formula. But again, you're going to be able to do this on your calculator. You still want to know the formula so that you can plug in. But ultimately, we want to make sure that we understand what the formula is and how we can produce our confidence interval on the calculator. Okay? So example 3 says, since the conditions for calculating the confidence interval for P of U minus P of 1 were met in example 1, construct and interpret the 95% confidence interval for the difference between US and Italian adults who think brand names are important. So we already did the conditions, okay? But let's just go ahead and kind of remember the step process. So step one was state, okay? And that would be, we want the 95% confidence interval for the difference between US and Italian adults who think brand names are important when buying clothes. Okay. Now, the only part of the plan step that I'm going to incorporate is the test. Okay. This is now yesterday, if you remember, we did a 1 proportion Z interval. On the calculators, if you were to hit stat, go over to tests, and hit the up arrow to option B, okay, it's the one right below the 1 proportion Z interval, you'll see something that says 2 prop Z int. Okay, and that's what we're going to use here. This is a 2 proportion, right? One for each population. Z, because we're using Z as our critical value. Interval, because we are trying to calculate the confidence interval. Okay. Now, remember that the other portion of the plan stage is to verify the 3 conditions, but we already did that in example 1. Okay, so next would be the do step. Okay, and that's going to be p hat 1 minus p hat 2. So from the Skittles example at the beginning, or I'm sorry, that's not the Skittles example. Right here, this is our Italian. So 26% for US and 22% for Italian. So this is going to be 0.26 minus 0.22 plus or minus Z star. Remember, Z star for a 95% confidence interval is 1.96. And then a longer square root here, and it was p hat 1 times 1 minus p hat 1 all over n1. And our sample size for the first population was at 2309. Plus p hat 2 times 1 minus p hat 2 all over, I believe this was 1058, yes. Okay. And then from here, we let the calculator do the work. So again, go to stat, slide over to tests, 2 proportion Z interval. X1 is the number of successes in the first population, which we said was going to be 600. So X1 is 600. N1 is the sample size of population 1, which was 2309. X2 is the number of successes in population 2, which was 232. N2 is the population size of population 2, 1058. And C level is our confidence level, which was 95%. And when we calculate this, we get an interval of 0.00989 to 0.07126. Lastly, our conclude step we are 95% confident that the true difference in proportions between U.S. and Italian adults who think name brands for clothes is important. Running out of room here. Is between 0.00, and we'll just shorten this up, 0.01 and 0.07. Okay. So essentially, the difference is anywhere from 1 to 7%, or we're 95% confident that it is. Okay. Now, for the last question here, example 4, is there convincing evidence to support the claim that U.S. adults care more about brand names when buying clothes than Italian adults? And explain your reasoning. Well, what we want to focus on is if they felt the same way about it, if they felt the same way, then their proportions would be the same. And if we took the difference in their proportions, then it would be some number minus itself, which is 0. If Italians thought that it was more important, this number would be larger than this number, so we would get a negative number when we take the difference. And if Americans thought it was more important, that number would be bigger than this one, so when we do the difference, it would be a positive number. If we look at the range of values in our confidence interval, we have a positive number and another positive number. Basically, the key number we're focusing on is 0. Is 0 in the interval? Because if 0 is in the interval, that means it's plausible that these two populations feel the same way. However, in this case, 0 is not in the interval, which means this is pretty convincing evidence that there is a difference. There is a difference between the groups, and even more so, that the Americans' value is higher than the Italians' value because the difference between the two produces a positive number. Okay? So we could say something like, because 0 is not in the interval, there is convincing evidence that U.S. adults care more about name brands than Italians. Okay. So, what I basically just discussed is what's in this green box here as far as evidence goes. Due to sampling variability, the difference between the sample proportions alone cannot be considered convincing evidence. We can't just say, yeah, Americans were 26, Italians were 22, Americans are higher. Right? There's sampling variability that takes place. So what we do is we make our confidence interval and we look to see if 0 is contained in that interval. If 0 is in the interval, it's plausible that there is no difference between the two of them. However, if 0 is not contained in the interval, that gives us convincing evidence that there is a difference between the two populations. Okay? So, in example 5, if you want to try this on your own, you can, but otherwise just keep watching. Complete the do and conclude steps for a 99% confidence interval for the difference between proportions of red and green Skittles produced. Use our Skittles data. The 99% confidence interval is the 18% for red minus the 17.1% for green, plus or minus 2.58. That's our critical value for 99%. And then our standard deviation square root formula. Okay. In the end, we see our interval would have come out to be negative 0.0288 to positive 0.0466. We are 99% confident that the true difference between the proportions of red and green Skittles produced is between negative 0.0288 and 0.0466. So example 6, again, if you want to pause, write your explanation and see how you did, go ahead and do that. Otherwise, just keep watching. Example 6, referring to the opening activity, which friend would you side with? Well, we would say something like, because 0 is in the interval of plausible values, it is reasonable to believe Skittles makes the same percentage of red and green Skittles. Therefore, I'm going to side with friend B. Okay. Example 7. Patients with lower back pain are often given non-steroidal anti-inflammatory drugs like naproxen to help ease their pain. Researchers wondered if taking Valium along with naproxen would affect pain relief. To find out, they recruited 112 patients with severe lower back pain and randomly assigned them to one of two treatments, naproxen and Valium, or naproxen and a placebo. After 1 week, 38 of 57 subjects who took naproxen and Valium reported reduced lower back pain, compared to 43 of 55 subjects in naproxen and placebo group. Okay. So, part A, construct a 90% confidence interval for the difference in the proportion of patients like these who would report reduced lower back pain after taking naproxen and Valium versus taking naproxen and a placebo for a week. Okay, so what I want to suggest that you do here is pause the video, work through this example all the way through from very start to finish, and then resume when you're done. Okay. So here in the state portion, we want to know the 90% confidence interval for the difference in proportion of patients who report reduced back pain after taking naproxen and Valium versus taking naproxen and a placebo. Take the question, turn it into a sentence. Okay. In the plan phase, this is a 2 proportion Z interval. It's stated that this was random. Okay. And we also know that they were independent of one another since they are in 2 separate groups. 10% condition. Okay, it's reasonable to believe that 57 and 55 are both less than 10% of all patients with severe back pain. And lastly, the large counts conditions, we could have done either the way you see here with proportions, or just simply 39 successes, 18 failures for population 1, 43 successes, 12 failures for population 2, all of which are at least 10, so all 3 conditions are met. In the do phase, okay, 39 over 57 minus 43 over 55, those are our proportions, plus or minus 1.645, that's our critical value at 90%, times, there's our standard deviation, p hat, 1 minus p hat over n1, p hat 2 minus 1 minus, or times 1 minus p hat 2 all over n2. Okay, and the nice thing is, as long as you just write them in, again, you're not going to have to punch this into your calculator, so it doesn't matter how complex it looks. Okay, as long as you write them in, let your calculator do the work, and what we end up getting is negative 0.2342 to positive 0.03895. Step 4, our conclusion, we are 90% confident that the true difference in proportions between the 2 treatments is between negative 0.2342 and 0.03895. Okay? And then based on the interval in part A, what conclusion could be made about whether or not taking Valium along with naproxen affects pain relief? This is where we go and we check. Because 0 is in the interval, we can conclude that there appears to be no difference in pain relief. It's plausible that these 2 proportions are the same, which means if they're the same, Valium doesn't have any additional impact on pain relief in comparison to the placebo. Okay, and that's it for 8.3. So hopefully you see a lot of the similarities in 8.2 and the structures that go along with those. If you have questions, by all means, feel free to send me an email, or you can schedule an appointment with me during office hours, and we can meet then. I'll be happy to do that. The 8.2 homework is due Monday. The 8.3 homework will be due on Tuesday next week. Okay? Have a great day, everybody.